Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 3 from the October-November 2020 Pure Mathematics paper 1, variant 2 from the 97099 Cambridge syllabus. This question here, we have the equation of a curve given by y equals 2x squared plus m times 2x plus 1, where m is a constant. And the equation of a line is given by y equals 6x plus 4. We've got to show that for all values of m, the line intersects the curve at two distinct points. So basically, to find when two functions intersect, we solve the equations simultaneously. So in order to do that, we need to substitute one equation into the other. So I'm going to take this y and replace it by what y is equal to from the other equation. So I'm going to end up with 2x squared plus m times 2x plus 1 equals 6x plus 4. Now, we've got to show that for all values of m, that there will be two solutions to this equation. It will intersect at two distinct points. That means this will have two solutions. So the first thing we're going to do is, as it's a quadratic, I'm going to make it say equals 0. So I'm going to have 2x squared. Now I need to expand this bracket here to separate the x terms and the constant terms. That's going to be 2mx, and it's going to be plus m. And I'm going to subtract 6x from both sides and subtract 4 from both sides, equals 0. Let me collect together the x terms. Now 2x squared, I've got 2mx minus 6x, and I've got plus m minus 4 equals 0. So there's my constant term, they're my x terms, and that's my x squared term. Now what I want to do is write this so I have like a coefficient of x. So I'm going to take x as common. So if I have 2mx minus 6x, I can write this as x times 2m minus 6. So what I'm going to do here is I'll write the 2m minus 6 first. So 2m minus 6 times x plus m minus 4 equals 0. So here we have something in the form ax squared plus bx plus c. Okay, we have something in that form equals 0. So we have here a is 2, and b is 2m minus 6, and c is m minus 4. Now, we know that what helps us to discriminate or determine how many solutions a quadratic equation has is called the discriminant, okay, which is b squared minus 4ac. It's the part of the quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. It's this part over here, the part of the quadratic formula which is under the square root. That tells you how many solutions it's going to be. If this value of b squared minus 4ac is positive, there will be two solutions. You're going to have minus b plus something over 2, and you have minus b minus something over 2, two separate solutions. If it's equal to 0, there will be only one solution, which will be minus b over 2a. It will be plus or minus 0. And if it's negative, there'll be no solutions because you'll have minus b plus or minus the square root of a negative number which is undefined. So the line will intersect with the curve, okay, 2 times if b squared minus 4ac is positive. It will completely miss the curve if b squared minus 4ac is negative, and it will be a tangent to the curve if b squared minus 4ac is equal to 0. So we've got to show that b squared minus 4ac is going to be positive. So we're not going to start off by writing it that it's positive. We're going to just see what is the discriminant. Now, I've defined the discriminant as this triangle it normally is. So this is the discriminant of b squared minus 4ac. So the discriminant here is going to be b squared 2m minus 6 squared minus 4 times a, which is 2, times c, which is m minus 4. So I'm going to look at what this gives us as an expression and try to show that it's always going to be positive. So how do we do that? Expand the bracket here. So you have 4m squared minus, you multiply them together and you double. That's going to be minus 12m double is minus 24m, and then plus 36. That's when you square this bracket. And you got minus 8 times n, which is minus 8m, and minus 8 times minus 4, which is positive 32. All right, so let's simplify this. You have 4m squared. You've got minus 32m, and you got plus 68. 36 plus 32, 68. So this is the discriminant. Now, we got to show that this is always positive. And when you have a quadratic expression like this, which we have it for m, which is the formula for the discriminant here, we should try to complete the square to see what the lowest value this can be is. It's a quadratic type of situation, so we're going to complete the square. So to complete the square, okay, now don't divide by 4 because this is the value of the discriminant. Don't do stuff like dividing by 4 and stuff like that. No. What I'm going to do is I'm going to consider these two terms. There's two ways I can complete the square here, but I'll stick to my normal way. So I'm going to take out 4 as a common factor of these two terms. I just want this to become m squared. So m squared minus 8m plus 68. I'll leave that out of it, right? Then I'm going to concentrate what's inside here, and I'm going to complete the square for that. So I know this is going to become 4 times. This is going to be m minus 4. If you complete the square, you're going to have to write m minus 4 squared. So this letter without the square, the same sign as between them, and half the coefficient without the letter m. M minus 4 all squared. If I square that, I'm going to get m squared minus 8m plus 16. I don't want the plus 16. I'm going to take away that 16. Okay. And then I'm going to close the bracket. I'm going to put plus 68 on the outside. I haven't taken out the 4 from the 68, so I'll leave that on its own. Now I can take this 4 and multiply it by these two terms. 4 times this and 4 times that. So let me write that on the next line to give myself some more space. So I'm going to have 4 times m minus 4 squared minus 64 plus 68. So what we'll end up with here now is the discriminant is equal to 4 times m minus 4 squared plus 4. Now I know that this is always going to be greater than 0. I know that m minus 4 squared must also always be greater than or equal to 0. And 4 times m minus 4 squared must also be greater than or equal to 0. For all, and this is for all m values. So therefore we can say the discriminant is going to be always greater than or equal to, or greater than 4. The discriminant therefore is going to be greater than 4. Therefore always positive, therefore 2 solutions. Okay, so if the discriminant is greater than 0, okay, for all m values, which we've shown, therefore we will have 2 solutions. Okay, is it asking us for solutions, or it says they will intersect twice? 2 solutions, okay, for all m values, therefore 2 intersections. Okay, the 2 solutions means 2 intersections. So you should write something like this at the end to show your proof, complete your proof. Sorry about my bad handwriting, but you try and be neater than that. Okay, so there's question number 3, completed from October, November 2020. Okay, it's important that you don't start off by saying b squared minus 4ac is greater than 0 and like use that as a, start like writing that as an inequality and trying to solve it. That doesn't work. What you do is you show that the expression you get will always be greater than or equal to 0. Okay, and you do that by completing the square. Okay, when you've got this over here, you know that this thing is always going to be squared. So it's always, whatever goes in here, even if it's negative, it's going to be squared, it's going to become positive. The lowest it can be is 0. When, m is 4, that will become 0, right? This particular thing here. 4 times that will also be, it's not going to be negative. It's always going to, not make it negative. And when you add 4, it's going to just increase it. So this will never, ever be negative. The lowest this gets to is going to be plus 4. Okay, that's the lowest value this can ever have. The discriminant will never be lower than 4. That means it's always positive. That means there's 2 solutions. That means there's 2 intersections. Okay, because this equation was formed by the intersection between these two by substituting them into each other. Okay, there's also an alternative way of completing the square for this, because this is a perfect square. So we could have written it as, we could have completed the square in a slightly different way, because we have 4 as a perfect square. So we could have written this as 2m, okay, squared. That's going to give us 4m squared. Now, what do we write here? Well, we know that this times this, so 2m times this, which let's call it p, times 2. If you multiply these together and double them, you get minus 32m. The middle term will be found by this times 2. So we can see here we're going to get 4m times p equals minus 32m. So p is going to be minus 8. So this will be 2m minus 8. Okay. And then when you square this, you're going to get minus 6. You're going to get 64. We don't want the 64. If I square this bracket, I'm going to get 4m squared. I'm going to get minus 32m. I'm going to get plus 64. I don't want the plus 64, so I take away the 64. And then I got 68 at the end to add. So I end up with 2m minus 8 squared plus 4. And then this, we can see, this is always positive. This is always greater than or equal to 0. Plus 4, that's also going to be always greater than or equal to 0. So very similar. From here, we can say 2m minus 8 all squared is always going to be greater than or equal to 0. Plus 4 is going to be greater than 0. Therefore, there's going to be 2 solutions. So same reasoning after that. It's just an alternative way of completing the square. When you see this is a perfect square number, you can complete the square in this way instead. That's perfectly fine. Okay, so that's an alternative way of answering this question. Other questions from this particular paper can be found in the playlist that will appear over here. Other questions from the topic of quadratics from P1 of Cambridge can be found in this playlist. I'll also include the playlist for P1, which are very similar questions in quadratics from NXL. And you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.